Hello, everybody. Good afternoon and welcome to this lightning talk. Thank you so much for joining. So according to a Department of Homeland Security's recent cybersecurity report, more than 2/3 of cyber incidents now originate at the network edge, the very point where users, devices, and data meet the cloud. That's the front line where every millisecond counts. And it's exactly where Sophos is planting their new edge defense systems, powered by AWS Local Zones. In this short talk, we will show you how we can turn that statistic on its head, delivering low latency protection right where you need it, right where the attack surface is. So my name is Ben Lavasani. I'm a hybrid cloud specialist with AWS, and I'm honored to be joined today by John Peterson and Simon Reed, both from Sophos, who I'll be handing over to in a moment. But just before we dive into the details, I just want to give you a small bit of background on Local Zones so you're familiar with the concept. Local Zones is part of our hybrid edge portfolio, and we're building a continuum of AWS services where our customers need it. And it always starts with the regions. We're going to continue to innovate and expand our regional infrastructure, but we get customers that need to get closer to their endpoints. These could be in metro areas distributed around the world, as well as on-premises environments and the far edge. And we're building this in a consistent way using the same APIs, familiar services, as well as same tools for automation, so that you're able to use any of these services across that portfolio in a very common portfolio way. So Local Zones, they're managed and deployed by AWS, expanding into metros around the world. They're designed to allow you to meet low latency workloads as well as local processing. You can run on-demand Elastic in a local zone, and we extend a parent region. So for example, we have one here in Las Vegas that's connected and extending the Oregon region so we can reach AWS Cloud locally here in Las Vegas. You can also use them in hybrid mode, so you can extend to the region and use regional service as well, and we have many customers that do that. And of course, they're integrated with the same APIs, just like I mentioned before, and others. And here's a short map just to show you where their locations. We started in the US, so there's the vast majority are there. All the purple ones are generally available, and then the white ones are all in planning. But we're expanding into Europe, Middle East, Africa, as well as Australia, New Zealand, Asia Pacific, and South America. Here's just some examples just to show other locations of how we're extending. So you can see some of the proximities between local regions. It's quite far. So there's a lot of value in latency as well as residency. So that was a very short, brief background. This lightning talk is mostly about the Sophos team. So at this stage, I would like to hand over to JP. Thanks, Dave.
All right. Hello, folks. Can everybody hear me? You can? Great. I'm John. I'm the Chief Development Officer at Sophos, which means I look after engineering and product development for the company kind of as a whole. I work closely with Simon Reed, who you'll be hearing from in a moment as well. So my main task here today is to give you guys a quick kind of Sophos crash course so you know kind of what we're all about at Sophos. So to start off, Sophos is one of the first cybersecurity pioneers. And we were one of the first companies that started doing AV back in the mid-'80s. And since that time, we've obviously diversified our business. We've reinvented ourselves many times. And today, we're one of the largest cybersecurity vendors in the world with over 600,000 customers and 25,000 channel partners that service that customer base. And for that reason, our primary mission is really bringing positive cybersecurity outcomes to the masses. Our view is every business deserves a superior cybersecurity outcome, regardless of their size. And our mission over the last 40 years has been to make that a reality. So cybersecurity, as you can probably imagine, and you can see from this lovely funnel on the left-hand side, or the right-hand side, is a very data-intensive business. So if you look across our entire portfolio today, primarily driven by our extended detection response and managed detection response offerings, Our systems process over 223 terabytes of raw data every day, and from all that payload, we extract 34 million unique detections every day. We block 11 million threats, and we surface 1,100 cases for our MDR teams to analyze and investigate, which ultimately results in over 200 real threat actors being stopped every day within our customer base. So we're quite proud of that fact, and you're going to hear a little bit more about how Local Zones has helped us achieve those outcomes for all those customers. So Simon, I'll pass it over to you, and you can cover that for everybody.
Thank you, JP. So you've obviously seen the sort of scale of our product and services deployment. I'm responsible for threat intelligence at Sophos, and this is effectively all the decisions and intelligence that enable our products to inform and protect our customers. So the key thing about threat intelligence is it needs to be available in a number of locations. Yes, it's in our product. Yes, it's in the clouds. But really the key component here is it has to work as a systematic sort of unit. We're here today to really talk about one of our key elements of our global infrastructure, and that is SXL, Sophos Extensible List. This is effectively a service we provide in the cloud built on AWS, which effectively connects all of our products and services back to our threat intelligence cloud. And as you can see, we've been through many iterations of this. It was first developed in 2007. We're on the 4th generation of this technology. It is absolutely critical to how we get intelligence into our products and into our customer base. Where we are today, or where we were historically, is this was deployed as a sort of set of large services across 5 AWS regions. And as you can see from the numbers, it is extensively used. Every single one of our products is effectively permanently connected to our threat intelligence platform. Now, some of these numbers look large, but compared to a number of companies who are here at AWS today, they've got larger numbers. There's one key differentiator with these numbers. We are in the business of stopping attacks. This means our products are in line, they are effectively halting function within our customer's estate. And our products effectively have local decision making, which is particularly fast, but at times they need to reach back out to our threat intelligence products. So this effectively installs some latency within our overall systems. There are very, very few actual places, services that are deployed where latency is this critical. So moving on a little bit. So what we were facing here is effectively a wide spread of latency across our customer base in relation to this service that we were providing. And effectively we're in a situation with the sort of lower graph here, which is our original service, where the sort of latency spread in a sort of bell curve around the planet. And we have a global customer base spread in nearly every country around the world. The situation we had here is obviously a sort of medium and low latencies. We're in a good position here. We're not slowing down a customer's traffic, whether that be their endpoints, email, their firewalls, or their cloud infrastructure. But what we were finding is once latency got into the higher regions, we were effectively slowing down or impacting the ability of that customer to function in a sense from a performance point of view. And in a worst case scenario, when latency got to sort of very high levels, effectively there were timeouts in the product, threat intelligence wasn't getting to our products, and effectively the trade-off there was not just degraded performance, it was degraded threat intelligence. We undertook a project with the Local Zones teams here to really make a dramatic shift in the global latency of how we were providing this service. Okay, and effectively move that bell curve dramatically into the lower sort of areas. So the key thing here is this is where we started our journey. Our service was deployed effectively in 5 regions, 5 AWS regions serving large geographic areas. And what we found with this analysis is there was a large degree of variability in latency in each of these areas. Now, obviously, as you'd expect, between North America and South America, there is a large distribution naturally. But obviously, even within the United States, there is a significant variation of latency from our customers' perspective from using AWS Regions. This is an example when we moved to effectively local zones in one area, and this is actually South America. Red is effectively highly degraded latency in our products in that region. Yellow is, sort of borderline, and green is within tolerances. As you can see, this is effectively when we deployed local zones, we moved that SXL service actually closer to our customers. It made a dramatic difference to the overall latency distribution within that sort of customer base. So this is where we are today with effectively the deployment of our local zones. You can see on this funky diagram, you can see effectively the regions in the larger areas, and you can see our deployment of local zones. And we're in sort of mid-cycle here in relation to deploying these. And we are focused primarily on Latin America and North America in these areas. And where we're going effectively with this is we're turning the problem on the head. When we started this journey, we really did not want to get into a manual assessment of which local zone we're going to be in. We are effectively changing our deployment strategy in relation to this technology, where we will deploy to a local zone by default. We will deploy to a local zone by default. We will then dynamically measure the changes in latency for the customers in that regions. And then on the back of that real world measurement, we will effectively determine whether we keep that local zone in place because it provides value to our customer base from a latency point of view, or it doesn't, and we effectively remove ourselves out of this environment. The dynamic nature of this is effectively because the sort of upfront analysis of whether we should deploy to a local zone or not is actually particularly challenging with the complexity of the internet, the complexity of how it's wired, the deployment from our customer's perspective. So effectively, we're going down a route of deploy, trial, measure, and then understand in relation to what we're doing. Now, it wouldn't be AWS without an architecture slide. We were told in advance we had to have an architecture slide. So here it is. So what we have here is our products and services that talks to an AWS local zone. We're based on effectively some sort of core technology of EC2 and Route 53, and that effectively talks back to our larger existing regions that actually contains all of the complex architecture and alike. The interesting thing here is effectively we moved a very sophisticated caching layer from effectively the region to the local zone. Our architecture allowed us to do this and effectively get a deployment effectively getting our sophisticated caching closer to the customers that actually yielded all of these results. Okay, so it's all well and good in the lab. It's all well and good measuring things, and then, just as you're sort of trialing this technology, interesting things happen. So this was our first ever local zone deployment. It was done manually from the team to effectively trial the technology, ensure we actually understood how it was behaving in practice. And it was in Florida, okay? And we deployed the local zone. We had the team watching all of the metrics. It's all ticking along nicely in normal circumstances. All lights are green on this. And then suddenly, Hurricane Milton appears, okay? We were faced with a situation where effectively hurricane moves through Florida, major power outages through the whole Florida region. In certain cases, days without power within that region, okay? And then ultimately the recovery starts, where things come back on, computer systems and lit up. The interesting thing here is obviously the top graph is our normal sort of daily sort of traffic flow through that local zone region, as you can see, and that's all in sort of units of 1,000. The bottom graph is what effectively happened in the few days following Hurricane Milton. What is happening here is computer systems are being turned on en masse as power's coming back on. And what has happened from a product point of view is all local caches have been blown. And also our product is also tuned that on effectively a reboot, you rescan systems and capability. So you can see a dramatic uptick in the volume going through that local zone. The good news is it all hung together, all auto-scaled, and there was effectively continuous service from our threat protection through this period. So again, it's a really good test of the system and something the team are very proud of. So last but not least, what are the sort of takeaways from this point of view? We always knew there was an opportunity out here to reduce latency of this service, okay? We had debated a number of times, do we just deploy to more regions? And we'd never felt like that really was a game changer for us. That would have improved the situation in a number of areas, but was it a fundamental change? So we were effectively sitting here knowing what the problem was and sort of being unsatisfied with effectively our route out of this. And then we saw the local zones announcement, and it took all of sort of 60 seconds of reading the press release and all the information about local zones to go, this is our opportunity for the game changer. Secondly, strong architecture is enough. We made this change relatively easily because of the architecture we had in our threat intelligence cloud. But it wasn't just the architecture that helped us. We truly understood the dynamics, the data, the metrics, and the interactions between our front-facing caching layer that effectively formed the basis of what we moved into local zones and effectively the back-end threat intelligence services. So we understood that before we made any changes. So again, it's not just the architecture, it's actually the flows and metrics through that architecture are really critical. It's been really helpful on this journey to have immediate contact with the local zones teams. So as soon as we saw the press release, as soon as we knew we wanted to do this was the game changer for us. We reached out to our AWS account rep and we got directly in contact with the local zones team and effectively push hard our vision of what we wanted this to be. So at the time they announced it was US only, and we were like, wait there, what about the rest of the planet? If we're going to do this, we want to touch every metro region. Okay, and we work with the local zones team. So the takeaway there is, be bold with the AWS service teams. And last but not least is, the services we all build are complex and sophisticated. Okay, it is hard to predict with high degrees of accuracy what will happen in real life. So again, deploy early, measure, and then when circumstances like a hurricane happens, use it as an opportunity to effectively stress test what you're doing and take benefit from that. So thank you everyone for this talk. I'm going to be standing at the back with John Peterson, who is over there. Very happy to talk more about what Sophos does, low latency environments, and the sort of spread of where we have threat intelligence and why this is so key to what we're doing going forward. So thank you everyone.